All right, this is the first lesson of Unit 1, kind of Tools of Geometry. We're going to be focusing on points, lines, and planes, and some basic facts about them, how to notate them properly, which is really important for the remainder of the year. And so this is a foundational lesson that we're going to use in this unit and beyond to be able to identify in problems what symbols mean, which will inform how we're able to solve those problems. So there are kind of four types of geometries that we're going to start with: undefined terms, defined terms, postulates, and then theorems. So we're going to begin with the undefined terms. They are terms that cannot be used, not be defined by using other figures. Okay, so points, lines, planes. We'll have a general description of what that is. Let's do red here. All right. So one of the differences which we'll get to is between postulates and theorems. You use postulates to help prove theorems. Okay, so theorems are true statements that can be proven. All right, we'll see more what that exactly looks like and what that means in terms of geometry coming up here. So we'll define postulates as well coming up soon. So, all right, undefined terms, they cannot be defined, hence they are undefined by using other figures, points, lines, planes, etc. So a point is one of those terms. It names a location and it has no size. Okay, and it is represented by a dot. Okay, and you can see there in the diagram there to the right, specific points. And if I was going to name them, the proper way to name them is to say point A. Okay, you can also use kind of a shorthand, PT for A. It is really important. Points are capital letters. Okay, so if you see that in the diagram, you know a capital letter represents a point. Okay, space is just all points that exist. There is no specific notation for that or diagram to describe that. Okay, but a line, as you may have guessed, is a straight path that has no thickness and extends forever. So it never ends and never bends. A curve and a line are not the same thing. Okay, so the important thing to remember is that to notate this, you use 2 points on a line or a lowercase letter such as this. So if I had a line over here, and I had points X and points Y, and this was L. Okay, I could name this, and here's the symbol that must be over top, XY. I could also name this YX. There is no difference between that line, or I could describe it as line L. Okay, so any of those are sufficient to notate it, but you need the symbol above the 2 points. You need 2 points, cannot stress that enough, on a line, or if it is named a lowercase letter. A plane is a flat surface that has no thickness and extends forever. Okay, so kind of think of a flat floor, okay, a tabletop, even a wall. It could be a vertical plane, many different examples. Okay, so whereas a straight line, I needed 2 points. A plane, I use 3 points. Or a capital letter. So if I see over here, what I mean by capital letter is that R there is not designated to a point. It is by itself in the corner of the plane. And so I could name it plane R. Okay. but I have these 3 points here. Okay? And so I can name this plane A, B, C. I could also name the same plane CAB or BCA. Any combination of those 3 would be sufficient, okay, in order to establish a plane. So 2 points is not enough. That gives me a line or a line segment or array, which we'll get to those things later. 3 points. It is possible to use 4 points as well. Can establish a plane. So I need to make sure I have the correct number of points to represent a plane. Okay, so collinear points. Okay, the co in the front, okay, should tell me to share, and then a line. So these are points which lie on the same line. Okay, they are collinear. Okay, so with this example over here, I can say points G, H, and I are collinear. Okay, but any other J, I, H, H, I, J, I, H, J. I mean, you can bunch of different combinations. Those are all collinear. And as you might guess, something that's non-collinear means that points which do not lie on the same line. Okay. Okay, you still, and this is important, you still need to have 3 points. Okay, and so 2 on a line, 1 off, because any 2 points connected forms a line. Okay, so one of them has to be off of that line. They cannot be collinear. Very, very important. So, example here, points G, H, K are non-collinear. So you can see that 2 of them are on a line, 1 of them is off. So they are non-collinear. Okay. All right, next we have coplanar in the same sort of way that co meant to share. Okay, in this place it's coplanar. Okay, then they are sharing the same plane. Okay, you can have lines that are coplanar as well, and so they are on the same plane. Okay, and an important detail again is you need at least 3 points. Okay, very important. Okay, you have to, with 3 points, you establish a plane. So you have to, when you're describing points or lines that are coplanar, you have to establish what plane you're talking about so I can refer to the other points you're describing, whether they are on that plane or not on that plane. Okay, and so as you can imagine, a non-coplanar are points which do not lie on the same line. Okay, so we have some diagrams above us. We look at diagram W. Okay, it's a flat plane. It looks like all 4 of those points and line AD are all coplanar. They are on the same line. Okay, and so we could say that points B, A, D are coplanar. Okay, they're on the same plane. Okay, but now I have 2 separate planes. I got kind of the red one going horizontally and the kind of bluish purple one going vertically. Okay, and so if I wanted to establish things that are coplanar, okay, I could say that maybe line BD and line AC are coplanar. Okay, you could also say that points A, B, C are coplanar. They make a plane. Okay. You could have said that, A, B, C, D are coplanar. You could have said that just the same, and that would have been fine. You cannot say that A, B, C, D, and E are coplanar. They are not. E is on a separate plane. But you do notice that B, C, and D seem to be at the place where two planes intersect. That actually forms a line, which we'll see in the next page of notes. So you could say that B, C, D, and E are coplanar. Okay? So you can also say that points B, C, D, and E are coplanar. Okay? So certain points can't actually share two planes simultaneously at the point of intersection. Okay? All right, hopefully that is clear. Okay, so to describe non-coplanar, okay, this is important. Okay, so I could say that points B, C, not those. We'll say A, B, C, and E are non-coplanar. All right. ABC established the plane because you need 3 points to make a plane. So that's the vertical blue plane. But E, we can see, is on the horizontal red plane. And they are not on the same plane, so they are not coplanar. So you need a more than 3. Okay, so minimum of 4 in order to say that those points are not on the same plane. Okay. And so if we look at Z diagram, I think that's supposed to be, we just established that up there. Okay. So this is for the next sets of notes. Okay, so I want you to try examples 2, 3, 4, and 5 on your own based off of the notes we just did. So you can pause the video, try it out, and then turn the video back on to see if you are tracking. So it is named line T. You can see that it is a lowercase. It is not on a point. So we can name it line T. I see that G, H, I, and J are on the same line. F and K are off the line, or they are non-collinear. Okay, so I want to look at that and name it 3 different ways. So I got to make sure I use the proper symbol. I could say GH, line GH. I could also flip it around, say line HG. I could also say that line GJ. Then you can, any combination of those 4 would be ways of naming that specific line, line T. Okay, so name 4 collinear points. Points G, H, I, and J. Okay, you got to make sure to put points in front of it. I just don't want to put G, H, I, and J. You will get marked off on your quizzes and tests. We got to label it. We need some type of unit to make sure we know what we're talking about. Identify 3 non-collinear points. Remember, 2 have to be on a line to establish a line, and the third point is off of that line. So I could say that points G, H, K are non-collinear. G and H are on the same line. K is off of that, so they are non-collinear together. All right, so draw 4 coplanar points, points A, B, C, and D in plane W. All right, so this is just trying to take a description to see if we can create a drawing, which is always a good thing to do in geometry, to visualize what you're describing so that you can then focus on what the question might be asking instead of trying to imagine it in your head. So draw a plane, could just be a box, whatever you want it to be. You could try and make it more artistic if you are an artistic type. I am not. We're going to name it W, and then I just have 4 points here, A, B, C, and D. So I've drawn a plane. In the corner, put capital letter W. Is not with a point, so I know that is just describing the plane. And then A, B, C, and D are separate points on there. All right, now we're going from undefined terms that don't use other things to define it to now defined terms. So a line segment, endpoint, ray, and opposite rays. Okay, so a line segment is part of a line, as the word might suggest, a segment. It's a portion of it consisting of two endpoints and all points between them. Okay, so if I had a segment over here, got an endpoint, let's say I named it AB, and this one's just a line, no arrows for a line segment. BA, I could also have named it, AB, I could have named it BA. Either one is fine. I need to have that bar above it with no arrows to define it as a line segment. All right, an endpoint. Well, a line segment requires two endpoints, so if we define it, okay, a point at the end of a segment or the starting point of a ray, okay, which is the next thing we'll define. So it kind of seems a little bit strange. Call it an endpoint, while it also could be a starting point for something else. Okay, and so if we had a line segment again, let's say C and D this time, okay, point C and point D are both endpoints. A ray now is a part of a line that starts at an endpoint and extends forever in one direction. Okay, so if I had something that looked like this, I got an arrow on one side, endpoints, point on the line, let's call it RS. And let's say we had one going the opposite direction. And so we had over here S, and we'll rename them. We'll call it X and Y. Okay. So the symbol is an arrow to one side, and then I must start with the endpoint first, which is the starting point of the ray. So that would be R, and then S. Ray RS. Okay, so down here, you still want to draw the arrow going to the right. That's just a standard symbol for ray. So whatever direction the ray actually is on your diagram is irrelevant. You just put the arrow going to the right. But I must start with my endpoint, so that is X and then Y. Okay, so ray RS and ray XY. Opposite rays are two rays that have a common endpoint and form a line. Okay, they never will overlap. Okay, so really it just kind of looks like a line, except we have a point here that we're building two rays from. We can call this ray XW and ray XY. Notice that the common endpoint is the first one that is listed. That is important. Okay, so basically is a line with just 3 points on it, and we're establishing a ray from the point in the middle, extending in each direction for opposite rays. Okay, so same thing, 6, 7, 8. Try to pause the video, try it out yourself, and then restart the video to see if you were on the right track. So a segment with endpoints RS is just this. All right, if I drew it, and I would name it RS, I can also name it SR. Either one is sufficient. Okay, I see the arrow going to the right, AB. That tells me that I have the endpoint or starting point of the ray is A, and then a line on there is B, extending in one direction forever. And then the opposite rays with the common endpoint Q. Again, just you have a line. This is going to be Q. Okay, and let's say you have an A here and an R there. Okay, so can you name two opposite rays? Yeah, sure. We got ray QR and ray QA are the two opposite rays. All right, so we've done undefined, defined. Now we're starting with a postulate. Okay? And so this is a statement that is accepted as a true proof, actually, as true, I should say, without proof. Okay. So it doesn't mean that it's something made up or imaginary. It just means that I don't need to write a proof, which is a geometry term that we'll get to. I don't need to write a proof in order to make this a true statement. It's been accepted as true, and we'll see that kind of seems self-explanatory. So you do not need to memorize postulate 1 is this, okay? But there are understandings that will help you solve problems, answer questions, and then write your own proofs moving forward. So there isn't postulate 1 here that is established as postulate 1 everywhere in the world. So if you walked up to someone in another country and said, hey, you're in a geometry class, can you tell me postulate 1? They wouldn't know what you're talking about because we're just kind of summarizing different postulates that are good foundational parts to geometry, okay? And so you don't need to memorize them, but you do need to get familiar with them because you will need to use them again. So we're defining postulate, the first postulate as through any 2 points there is exactly one line. Okay? There's one line. Okay, so real world application, just think kind of the shortest distance. All right, the shortest distance between 2 points is a straight line. You may have heard that, said that before. Okay, so it's just saying that if I had line XY, let's do it. Okay, line XY, okay, that between those 2 points, the line that you can create, there's only one line. You can't create a second line that goes through both of those points that's any different than the line that already exists. Okay, so if you have 2 points that you connect infinitely in each direction, it can only produce one line. Okay, so think about leaving a building and you're going to go to your car. Okay, you see your car, there's no obstacles in between you. You just go from outside that door directly to your car in a straight line. That they're kind of like 2 different points, that line that you make. There's no other way to, without bending, to go from that door to your car that's different than what you did. Okay, and so if you curved and things, and it's no longer a line. So that's all this is saying. Okay, that between 2 points, if you connect them straight, there's only one line that can be created. All right. So postulate 2. Postulate 2 tells me that through any 3 non-collinear points, so through any 3 non-collinear points, there is exactly one plane. So they're almost kind of defining these things. Okay, so think about a tripod, right? If you pull out a tripod for a camera or something, or a telescope or something like that, those 3 points on a line need to be on a flat surface in order to, and that flat surface then is kind of the plane that would be established. All right, so if I had this, and I had A, B, C, okay, then that would make those 3 points connected in each direction would give me a plane. Okay, so just think for a second, why must they be non-collinear? Well, because if I move that B up in line with A and C, so that one line passed through A, B, and C together, I didn't establish a plane in each direction. All I did was make a line. So it would not be a plane if they're collinear. That's why they need to be non-collinear. All right, so another one here is if 2 points lie in a plane, then the line containing those points lies in the plane. So if I had some plane here, I had a line in it. That was X, Y. Those 2 points that make a line on the plane, and those points are on the plane. So if the line's on the plane, then the points on the line are also, by definition, on that plane. Okay, so an intersection is the set of all points that 2 or more figures have in common. So they are, whether it's a line, whether it's a plane, those that share each line or each plane, is what happens at an intersection. So we'll see what this looks like here. So if 2 lines intersect, then they intersect in exactly 1 point. Okay. So just try to think. 2 lines, 1 point. Okay, so an example of this is roads, right? You had one going in that direction, one going in this direction. They intersect simply at 1 point. We'll call it A. Okay. But if 2 planes intersect, then they intersect in exactly 1 line. Okay, so, example where 2 walls intersect, okay, is an example of a line created by 2 planes intersecting. Okay, so again, just think kind of 2 planes, 1 line. Walls. All right, just trying to give you a small phrase to try to keep some of these in the back of your head. All right, so if you had a, why is doing that? And then you had something going out in the other direction. Okay, that point establishes a plane. Okay. You'll see it as a better picture down below. All right, so again, it says always learn the statements of the postulates and theorems. Okay, you're never going to be asked to name them specifically. What is postulate 4? And that notation 1-1-3 is kind of a standard notation for different postulates. We're just trying to simplify it for you at this point. And so you're never going to be asked to name them, but you should be able to give us an understanding of what they actually mean. All right, so pause the video here and try doing 9, 10, and 11 on your own, and then start it up to check to see if you're on the right track. All right, so if we look at diagram Z, examples 9 and 10, for 9, 10, 11 here, identify the intersection of line BD and AC. So I look and find BD is horizontal, AC is vertical. Okay, so the intersection is a point. Point C, that's the intersection. And I want to point out there in the background, you see kind of that dashed line somewhat underneath it. Okay, that is implying that it is behind that plane. Okay, or as you can see, the line going down, it's underneath it. So when you see a dotted line, it's telling you, it's trying to give you some perspective and depth to tell you where things at, so that on a 2-dimensional piece of paper, you can distinguish to some degree, some level of 3 dimensions. So that's what the dashed line means. All right, so what is the intersection of plane N and plane BCE? Okay, so this is a great example because you can see that, all right, plane M, you see that's down there. So that's the vertical bluish purple plane. And then plane BCE, it's labeled properly with plane, and it's got 3 points, which is absolutely necessary to establish a plane. So I got BC and then E over here. So we're talking the red, reddish-orange horizontal plane. So what is the intersection of 2 planes? Our last postulate tells us it creates 1 line. So you can say you can just give the symbol a line BD, or line DB, or line CD, or line CB. All those things are correct answers. Okay, so sketch two coplanar lines RNS intersecting at point. All right, so if you just had a plane there, and you just had two lines crossing one another, okay, that being R, that being S, and they intersect at P, all right? Okay, that's a lot, but it's a really important bit of notes. So you're going to want to really stress the notation. That's kind of the lines, the bars, the rays. Okay, saying plane, points, or capital letters. All those things are important and details that you don't want to overlook and think aren't. So on your homework, really make sure you're being disciplined to use the correct notation when answering questions, because that you're going to be expected to do that on assessments. And you just want to get that down now and kind of do the diligent work to establish that in your memory so that it's second nature and you're not worrying about this or getting points marked off because you're not notating your answers correctly. All right. Hope you learned something. Come ask any questions if you have any. Thanks for watching.